Hello everyone. Welcome back. I did a pretty short stream this morning. I thought I'd also try to do a short stream tonight. And then it ended up being a lot later than I was aiming for because the CPU cooler I was installing turned out to be a bit more of a complicated job than I expected. But welcome back to the stream, anybody who's showing up early or visiting in the archives. I was having trouble with this computer overheating. Well, not getting so hot that anything was failing or like refusing to run, but the CPU was getting hot enough to be concerning. Let me share some photos. So hi, it's dark here. I'm sitting next to the heater. Ow, the tea is still too hot to drink. Oh hey, we've got a smiley face from Pixel Bros 300 in YouTube chat. Hello. All right. Discovered a glitch with the KVM switch. My Windows workstation is asleep, and I think when I like am moving the mouse and switching the KVM at the same time, I can momentarily wake up the Windows machine, and then after it wakes up, it switches the KVM to its own channel. So it's like I'm switching through the KVM and it just hops back to that computer's channel momentarily. Oh, geez. Just noticing Morgan's chat that Sci-Hub has been ordered to be eradicated from DNS. Ugh, I don't even want to get into the politics on that in this stream, but geez, that sounds terrible. Yeah. Oh, Pixel Bros 300 is asking what I'm working on this late. Good question. Well, so I was, the thing that I just finished was upgrading the cooling on this computer, but let's look at this. So I ended up having to, where's the CPU? Yeah, so there's the hardware in this machine. I ended up having to take the CPU cooler completely apart, and so there's the old cooler on the top, the new cooler on the bottom. And annoyingly enough, the bracket actually did not fit because I think the one I had was somewhat non-standard in that instead of just having like 4mm diameter holes, it had these captive nuts pressed or welded into the assembly somehow. So yeah, the captive nut on the right was not helping. So I ended up having to take that to the drill press, and then I finally got the new cooler on there, and it's much happier now. If we're going over here, I've got this running basically the same workload that was bringing it up to like 90 degrees Celsius before, and it's staying around 70, which seems much better. So that was the first thing I was working on. That's what kept me so late. The other thing I was doing earlier today, I was doing a bunch of code refactoring. So I changed a bunch of the way that the menus here are organized. So there's just actually now one top-level thing, one top-level navigation. So this includes this sort of overall bot thing, which right now this just has the mode and a place for steering around the tracking with the joystick. And then there's a separate panel for gimbal, and then under there I separated this out so there's one that just has sort of status. It's got these big old motor on-off buttons, but then mostly it just has these graphs. We'll get to those later. And then all the configuration is in a separate setup tab. And then the firmware parameter stuff, this is like a glimpse into the gimbal's internal memory space. And right now it's not very filled in because we're only actually requesting some of this to be interactive. And this is a bit of a placeholder. Right now it's helpful for debugging the couple of things it actually shows, but it's also a placeholder for some more comprehensive gimbal debugging and reverse engineering tools later. And now it's just handy to have a separate place for that. This is the winch stuff from before. I don't have the winches plugged in right now. And then for the graphics overlay here, all the stuff we had before is in this setup tab. These are like colors and animation parameters and stuff. But then I also have this new one called layers, which actually duplicates just the alpha channels from a bunch of the objects there. So for example, I can adjust the opacity of those cat particles, or the raw tracking rectangle which jitters around, or the labels that actually have information associated with the rectangles, the object detector outlines, which we don't have any of right now. Anyway, the gimbal motor is not on right now. If I use the joystick, I can move around the tracking rectangle, and the computer vision, it will try to just match the same set of pixels that I stopped the tracking rectangle on. But right now, because it's dark in here and it's just pointed at nothing really, it's not very useful. So there's more of that we can experiment with. For now, I'm just going to kind of keep this out of the way. Oh yeah, we've got some debug text. That's a little bit annoying right now and not very useful. Sensors, which these are just the sensors on the robot. We've looked at these a bunch. And then in computer vision, this setup tab has a lot of the same stuff from before, just the parameters for the computer vision subsystem. And then in status, we've got some of the same graphs from before. Again, I'm keeping tabs on how long it's taking to do the two computer vision algorithms. So in parallel, each frame is being run through two different algorithms. There's a correlation tracker running on the CPU, and an object detector that runs mostly on the GPU. And you can see how long those take. The correlation tracker is most important to get a result from quickly, and so that one's tuned for relatively fast response there. I also added a graph to show the quality ratio of the tracking. So right now it's pretty low overall because I don't have much to track, but for example, if I go over here and track that image that actually has some texture to it, it shows a much higher quality ratio. This stuff over here is pretty bad. That'll be more interesting once the camera is aiming. And then I'm also just graphing the rectangle left and right sides, which will be more useful once we have something the computer vision is tracking. Oh, hey Kate, nice to see you here. Oh, Morgan asks if that's a Dell server board. No, it's just like a random Dell machine. It's not even a server. It's a random Dell machine that I've been upgrading and stuck in a 4U case. But yeah, I guess if this is a thing Dell does pretty commonly, then yeah, drill press CPU mod solidarity. Oh, that's a good question. From Pixel Bros 300 says, did you use a library for the gimbal movements? I'm not quite sure whether you're talking about like the way that I decide how to move the gimbal or the way I'm talking to the gimbal. But the way I decide how to use the gimbal right now is mostly coming from the from these two computer vision libraries. So the correlation tracker is from dlib, and the object detector is from YOLO/darknet. If you're asking about the graphs, then this is a bunch of custom stuff, plus the actual graph rendering is coming from a JavaScript library called Smoothie Charts. And if you're asking about how I'm talking to the gimbal, that's all custom and based on reverse engineering. But I'm open sourcing it all, and there's a Python implementation of it that might be relatively easy to hack on, and I have a work in progress port of that to Rust right now. So hopefully one of those answers your questions. If not, let me know. So yeah, this will be interesting soon. The actual next step here, I think, is I totally rewrote the way gains and just the way we calculate gimbal rates, like all of that is different. and none of it's been tested because I wrote it all while I was away from the robot, so I guess we should just try it. So right now the motor's off. Where are the gains set to? I think I've got the gains, oh, I was gonna say I had the gains mostly zeroed, but let's actually zero out the gains. I also rewrote the limiter. I've not tested the limiter. The limiter is what keeps the gimbal in software from hitting the mechanical end stops in the yaw axis or getting unstable in the pitch axis. And so I give it end stops up here, which are its targets, to try to not go past. In reality, it goes a little bit past them and tries to stiffly spring back. But I also added a feature where when you approach the limit, it also limits the maximum velocity, and it actually scales down the maximum velocity as you approach the limit. The maximum velocity in that direction. So, oh, and then I also have this overall maximum gimbal rate. So if it would try to be larger than this, it just like shrinks down the vector. So I think I actually want to keep this open and then also open this in a new window if I can. Oh man, that CPU is not that toasty. Alright, maybe I should also go through the code for this first because, you know, even just to remind myself what the flow is. But I also just kind of changed entirely how this works. Which was the plan. This was, I've been meaning to rewrite this part of the code. So, gimbal controller. This is just for like a UR here. This is in the Rust-based daemon. So Rust is a programming language. It's a systems programming language that's kind of a more modern replacement for C++. And I've been using that for this sort of central process that controls the robot. And so that's running on this same PC that we're staring at. And it communicates with all the robot components over Ethernet. There are a bunch of microcontrollers. And it's also using a capture card to get the video from the camera. The video is actually being processed by this instance of OBS, the broadcasting software. And in this flare camera input, there's a filter, which is actually running the computer vision, drawing the overlays, and communicating with the server. So that's just running over here, and then talking to the Rust code over at WebSocket. So this is the thing that the gimbal controller does every tick. So if you see, there aren't a lot of public functions here. There is value received, which the outer code calls when we've just received a new updated value from the gimbal, so we store it. And then there's tick, which is called once per control loop tick. And then this takes the tracked region, which comes from the computer vision. That's the part we care about is basically just a rectangle. And we might care about like the quality metrics or whatever, but mostly we care about the rectangle. And gimbal port here is how we actually communicate with the gimbal. So if we wanted to be sure to request a value from the gimbal later, or if we wanted to send a value or like queue a value to be sent, then this is how we do it. Under the hood, it's like a series of ports that we use to communicate with a different thread. Config is read-only access to the configuration file, basically, which can change at runtime. So this thing does not have to own a reference to the config file, it just needs to borrow it occasionally. Oh, that's a good question. Hal asks if I go by Micah or Beth. Kind of either. I've been mostly going by Micah lately, but I went by Beth mostly for a while, and I'll still answer to that, and it's still fine to call me Beth. I've just kind of been, you know, my middle name's Elizabeth, and so I kind of got tired of Micah for a while, and I went by Elizabeth, or Beth. But yeah, these days I've been mostly using my first name again. But yeah, that's a good question. It's always good to ask people about names and pronouns and things. I mean, not always. Like, it can be hard sometimes, but like, it's usually good if you do it carefully. Yeah, anyway, so the architecture here is basically that this gimbal controller, it owns a little bit of state. So it knows about like saved values from the gimbal, just like its last known value for all of its things. And so these values are things like where is it pointed, where have we told it to go, where is its calibrated center location. That's what it needs to know about so far. And then I have the integrated, well, these are like the integrators for the PI. So I didn't implement derivative because I didn't really care about derivative in this case, and I didn't really think the smoothing would be effective. So I just implemented a PI control loop, or rather a lot of PI control loops, as we'll see. And so we actually need to store several integrators for yaw and for pitch, and that's what we put here. In reality, I'm saying several, but it's probably only two. The way it's set up right now is that there are two separate gain regions for each axis. There's sort of like a soft gain region that's sort of wide and cushy, and then there's a hard region that's like very narrow and like very, very high gain when you reach it. And the idea there is to have some soft tracking that tries to keep the camera mostly pointed at, mostly framed right, but isn't going to be responsive enough to follow something that's about to go off frame, and that's what the higher gain region is for. That's the plan, at least. None of this has been tested, but the reason for this is that I need to store multiple integrators for each, and that itself might seem debatable if you've done any PID loops, but I think the reason for it this time is that I want the integrators to be able to reset independently, because in the current architecture I'm resetting the integrator anytime it's not accumulating. So you enter the gain region, the integrator climbs, and then you leave that gain region and the integrator instantly resets. And my theory there is that if you have an object and it's about to leave the screen, then as soon as it touches that region, you want to start going faster and faster until you can catch up with it. And then as soon as you actually do catch up with it, you want to cut off the integrated gain, and then you only have the other gains. So that's my theory. Let's see if that works. Oh man, Tuco is right behind me, and I've really got to get this camera working because he would be really good right now. Oh, what a good cat. Anyway, the middle of this really, we can go over the ephemera later, but the important part is that when the controller is operating normally, and it's got up-to-date data from the gimbal, and we're not halted or anything, we calculate the tracking. We take the integrated and the proportional based rates, add them together. We also add in the drift compensation, which is just, currently it's a small static vector that I just tuned by hand, but I plan to have that be closed loop as well in a little while. That's because if you just give the gimbal zeros, it still drifts a little bit. And so I don't plan on keeping the computer vision rectangle centered. I plan on having some hysteresis. So the combination of the drifting and the hysteresis means that eventually the thing you're targeting just drifts into one of the corners of that middle rectangle in the screen. So to keep that from happening for as long as possible, the drift compensation will try to null out that slow drift in the gyro. So I add that pretty soon. Then there's a limiter. So the drift compensation happens before the limiter. The limiter is what prevents you from moving, or it limits the velocity eventually to 0 once you approach the limit. And then once you go past the limit, it actually pushes you back. And then this clamp length thing. This vec2 clamp length is just like a generic utility in my vecmath library here that just takes a vector, and if it's less than this length, it stays the same. If it's longer than that length, it squishes it down to that length. And then dither rates actually just adds a little bit of random noise to the rates so that when I convert it to integer, I don't actually introduce a bias. So that means that I can still add little adjustments, especially on the drift compensation, and this ends up effectively kind of toggling between two adjacent integers at a kind of randomly, but with a proportion that averages out to the right number. So there's all the different stages. And then the outputs of this whole thing, the thing we actually care about in the end is actually pointing the gimbal. And so that's done by writing the control rates to this gimbal port up here. But For debugging and status and telling other components what's up and like drawing the overlay and whatever, just for generally getting status information out of this control loop, we have the gimbal control status object, which is returned. So we also end up just assembling one of those, and that includes the current gimbal angles, the rate that we're actually sending it, and then also just the tracking components, the tracking P and I components there. And so those are actually summed up if we go inside tracking tick. This is just the tracking component. And so now in here, those two pieces, the proportional and integrated gains, those are then calculated axis by axis here. And so this is actually done just using a closure here, so I didn't have to separate this out into a separate function with a lot of really dense types in it. Since this is only used here, it was nice to just make it a closure. And so here, I actually just have this code, which is pretty much the same code, but it needs some data to be different depending on whether it's operating on the pitch axis or the yaw axis. So I'm just calling it twice and then recombining the results. And what this code is doing, first is just some bookkeeping to make sure that list of integral states has the same length as the list of gains in case this is reconfigured at runtime. But then we're actually just iterating this loop over each of the individual gain regions. So in our current configuration, this will run twice, once for that kind of soft gain and once for the harder gain region. And it's looking at how far outside of the region we are, both on the upper side and the lower side. And if we are either stopped or we've kind of changed sides, we reset that integrator. And then we just integrate, and then this sums up the proportional and integrated results for each of those gain regions and returns it. So that's the pipeline we're dealing with. Let's see if we can get some good results out of it. I think the first thing I'm gonna have to do is just turn on the gimbal and stabilize it. I think all the gains are set to 0, so I don't think it should move. And then we can just use the drift compensation to null it out if we need to. I also might have some of the gains like backwards. There might be some missing signs, so this might just blow up. But the controller has an on-off switch. Oh yeah, Emily asks, was that tower heatsink the new one? Yeah, so the original heatsink was like a little 90mm fan on like a little aluminum cylinder. And it was alright, but it just kind of went into thermal escalation when the CPU was actually going at like 60 or 70% load or higher. This one seems to be keeping up much nicer. It's like a 90mm fan with 2 big towers of fins and heat pipes, and it's pretty nice. Which is why I didn't really mind having to take the motherboard to the drill press to get it to work. It seems to be trying to hit the end stops. No? You know, I turned off that debugging text and then realized actually I was using it. I didn't realize I was using it. So those seem to be zeros. Okay. That was weird. I thought I felt a mechanical end stop there, but it was really just the gimbal very decisively going to a completely arbitrary location because that was what was still in memory. There's still some work to be done on tidying up the interaction between our code and the gimbal firmware. For example, I think there are some numbers we should be zeroing before we power it on that we currently aren't. Wow, the computer vision likes the lamp. That's pretty cool. So, okay, where do I go next? I think we should try to carefully add some proportional gain in the pitch axis, or maybe in the yaw axis. The yaw axis is easier to keep stable. Oh, or can we try drift comp? Actually, why aren't we seeing drift comp right now? I would expect that to do something. Let me try both positive and negative. I don't see any effect for either pitch or yaw. I was looking for rates to do something non-zero. It's not halted, is it? Oh, this integral decay rate is old. It's not even connected, so you can see there's a number there. I should remove that. What's going on here? We have max rate, limits, more limits, drift. The max rate shouldn't go with the limiter. The max rate should go up here. The slow pan is fine. We're eventually going to hit the end stop. I don't even know what that heading should be called. The rates are 0. Let's look at why the rates are 0. Tracking P rates and I rates are also 0. I don't, maybe I'm getting ahead, but let's see if I can get a non-zero P rate. Okay, there's a non-zero P rate. And the rates proper are still 0. See the waveforms there? It's not bad. Rates are 0. So we know we're reaching this path. We know these are getting updated. We shouldn't be in halt mode. So this should be getting calculated as I rates plus P rates. And then drift compensation also wasn't working, so the problem is probably in the limiter. Let's check the limits. Whoa. Okay, this is acting like there's a comparison backwards or something. Okay, let's check over that code with the gimbal motors off. Are we confused about the meaning of distance here? I think the meaning here is it's the current value minus the limit. So that would be the distance past the limit. And the idea here is that you keep the sign matching the sign of the gimbal's coordinate system there, but then I specify either +1 or -1 here to indicate which direction is the outside. So this should say I've got one limiter where I'm taking the yaw angle, calculating the distance past the minimum, and then noting that the outside direction is negative there, and then do the reverse with the maximum and positive, and then the same thing with pitch. So we can try an example. So let's say we're trying to test the limiter for an angle that is inside the yaw limits. So in that case, let's look at this first one. This distance will be positive, and outdir will be a negative, indicating that outside is in the other direction. So that should tell us semantically, I guess, that that's inside. So this is negative. So we would be in this. So I think the idea here is that we know outside distance is negative here. So we're starting, so imagine distance is 0, we're right at the limit. Yeah, I think this part's wrong. So maybe this would be a good time to draw a little picture for myself and for everybody else. Yeah. I was starting out by drawing a number line with 0, but actually I think let's try not making this that concrete yet. So let's try this for the minimum limit. In this case, outside direction is negative. So we could draw that like that. Whoops. Like that. So then if this was our point, that would have an outside distance that's positive. Or no. Yeah, because this would be negative, that would be negative. Outside distance would be positive. So then in this case, we're using distance without the sign modifier. Why is this right here? I think this needs a limit too. Maybe these two things should be separate, the speed limit and the push. So the idea here is that if you're outside the region, we should try to push back into the region. Okay, so that's just going to be about the push. then so I want something where at outside distance greater than or equal to 0, I have a rate limit of 0. Then at, let me write this down. So if this is greater than or equal to 0, then limit 0. At 1, yeah, this is the perfect thing to do late at night, right? Is fix your math bugs. It has to have like inside distance. I don't know. So outside. So the idea behind this was to start at 1 and then let a negative outside distance decrease it down to 0. But I think I got that part backwards. So at negative extent, then the limit is 1. So that means, yeah, that's right. So that means as we get further and further inside the distance, if we reach this configured value called limiter slowdown extent, which is the width of that region where we're decreasing the velocity, if we get further than that, then we're at full speed, which is 1.0. And I should be clear that this only affects the inward direction, because we're going to allow the outward direction to move at full speed. Outside distance. Oh wait, yeah, I'm getting the polarity backwards here. I think part of my brain wants to think of like the thing that's inside as being the like exclusion zone, but I think it makes more sense for inward to be toward the origin and also toward the zone we're allowed to be in. And that's what I used defining out up here and down here. So this will be the amount of that proportion that we're using between 0 and 1. think that's also just our speed limit. Let's just do the clamps down here. Okay, and then we're doing this according to the direction. Let's just make this a little smaller. Alright, let's try that. Hey, the CPU is still not melting. I think our cooling problem is no longer a problem now. Yay. It's still pretty power hungry, but I think it's keeping it under control. Is that debug code still in there? I just saw a bunch of debug spew on the console. I think we're fine. I think I hadn't compiled it since removing those. Almost. Oh, wow. Ben has some kind words on YouTube chat. Ben says, I don't normally comment, but work like yours inspires me to be a maker. Thanks. Whoa. I appreciate that. Thank you. I try to share stuff that people might find helpful. I think I bang on the KVM switch senselessly more when it's late. Especially when I keep waking up my Windows machine. Oh, I see. That's an integer. Oh. I forgot to add in that R push. Thanks, Rust. Well... I'm gonna just do a syntactic experiment. I don't know if I can do this in Rust. That looks really weird, but maybe it's legal. Oh, maybe it's legal. I probably would have aired out immediately if it wasn't. Okay. Cool. I'm really not used to if being an expression, but it's pretty cool. It's certainly a lot less weird to read than the question mark colon ternary operator. Oh yeah, Emily says tower heat sinks also seem to scale up better, adding stronger fans. Yeah, speaking of fans, I also noticed there was a spot for a... is it a third or a fourth? An additional 120mm fan in the front of the case, so that should probably help too, keeping the air flowing past the whole thing. And like now, the front of the case, the back of the case, the CPU, everything is just like front to back airflow. So that should help a lot. Electron Ash on YouTube chat says, amazing amount of work has gone into this project, and I'm glad to see things like the tracking working now. Yeah, same on both accounts. I am also amazed at how much work has gone into the project. It has gotten a lot more complicated than I expected it to be. Hey, Duke. Kate's describing Ruby's way of doing conditionals, and it sounds like that's pretty similar to what Rust is doing. Speaking of Rust, the debug builds lately... So I haven't tried profiling the debug builds since switching to Rust Nightly. Maybe things were better. But the debug builds are really slow compared to the release builds, and it actually can't keep up with the incoming message rate, so the server ends up falling behind. So I've been waiting for the release builds to compile, which is a little slow. And incremental builds often work, but I've been having more trouble with them not working. I think I just get a little reckless with like editing source code while it's building, and then that confuses the incremental builds. I think I threw a hard bolt for Tuco. Oh yeah, this is reminding me of EEPROM microcontroller programming. I'm sure it doesn't help that I'm using up a bunch of the CPU for other things, but it's not like this is multi-core. Actually, what is it waiting on? It's not locked on the console, is it? No, it's this little one. It's just that little Rust process, that's all. I mean, I guess I wouldn't expect Rust C to be that multi-threaded, even if it is Rust. What's up, buddy? Well, we can drink tea. Oh, yes, here we go, finally. Yay. This doesn't seem to be connected. I guess I'll restart this OBS. That's a bug, probably. Oh, Tuco, you brought it back. Good job. Tuke. Okay. Tuco was distracting me, and then OBS opened on the other monitor. Alright, gains. Oh, why am I guessed again? I don't want to be guessed. Oh, I think I lost the key. Let's fix that. I should also recompile the web app. I've been running it off of the Devel server at port 3000, but that means the one at port 8080 is hopelessly out of date. Yeah, Tuco is pretty chatty. Hey, boy. I don't know where that one went. Maybe Tuco will figure it out. Alright, that's better. Okay. So the gimbal motors are off right now, but we can see what it would be trying to do. So this is the actual integer rate that we're sending to the gimbal. And so this would be actually trying to tilt the gimbal left and right. We don't have any vertical gains. Let's add at least a little bit of vertical pitch proportional gain. Okay. Let's see if we can test the limiter. Well, let's turn it on and then test the limiter. Hey, don't open that yet. Oh, the gain is backwards, at least in that axis. That axis too. Okay, I should recompile that. Whoa, okay. Let's make that change, but then I also want to see if I can test the limiter while we're here before recompiling. Whoa. Tuco's trying to open a box that's not time to open yet. Okay. Limiter gain. Getting some buzzing from the gimbal there. Oh, I see. I had that yaw limit set way too high. Whoa. See if I can try it now. I set it kind of artificially close. Oh, hey, Took. Nope, the tracking is not quite going to work yet. I don't know why the gimbal's making noise. I would investigate closer. I'm just actually having to concentrate right now to keep it from going unstable. I'm pushing it up against the limiter and it seems to be holding pretty well actually. So I think the limiter gain is fine. I think the regular tracking gains are just backwards. And this thing is really hard to fly with backwards gains. So let's turn it off and fix the gains. Okay, I think it's just a matter of swapping these two terms. Bunch of other ways to do it, but that's the cleanest. Oh yeah, Jeremy in YouTube chat asks, any plans to use sound to find the cat as an additional method? Yeah, this is something we've talked about. It's not necessarily one of the first things we'll try, but I'd love to try. So I mean, we could definitely locate to go with meows if we had enough microphones. The other thing that might be easy is actually locating the bolts that he plays with, because even when I'm not around. Or even when I'm like elsewhere, Tuco will just play with the bolts and like drop them on the floor and like play with the noise they make. And you could detect that with enough contact microphones. So I'm imagining some piezo pickups like glued to the floor here and just pick up those waves. You might even be able to triangulate the location. Ah, yeah, the text at the top here is actually kind of useful. Too big. Oh, I guess I'm missing some of the question, but is there a question about the microscope? A lot of people have asked about this microscope, and it's actually a pretty cheap, generic HDMI microscope. A bunch of other people have been using these, and they're actually really nice for the money, and there's nothing fancy. They're not a good lens. It's just like a really basic microscope, but it just happens to be like pretty solidly good enough. You can pay so much more for a microscope. I've got a glass microscope, which is quite nice for just doing rework by myself, but I can't stream that one. That X button is like, it's like it's like I'm aiming for a couple of pixels if I want to resize the window, and then the X is like all these pixels. Fitz law. The little cats have drifted so far. We could just play a strategy game while we're waiting for Rust to compile things. Actually, I could play that paperclip game. Does anybody here like the paperclip game? Universal paperclips? Oh yeah, Sodium says, I feel like I saw a turn any solid surface into a touchscreen thing that used the same piezo mic triangulation style shenanigans a while ago. Yeah, I'm sure that's been done a bunch of times. It's like, not a new idea, I just think it would be fun to apply it to Tuco. Alright. We got a big tracking rectangle. Okay. Sometimes, so when you start up the gimbal, if you're not holding it in a decent position, it's pretty easy for it to get stuck up against the mounting bracket. But I'm gonna take my chances. If not, I'll try it again. Nope. That's better. Oh, did it just track? Yeah. Gains are no longer inverted. Okay, so we have yaw, we have pitch, rate control, proportional, integral. So what is it like to just drive this around right now? Not bad, actually. This is basically 1D proportional control with hysteresis. And this actually might not be a bad starting point for the relatively slow settings. But I think next let's try the limiter. I'm gonna try it somewhat closer in than the actual end stop, so in case it goes unstable, I'm less likely to break something. Whoa. It is weird how the axes are different than you'd expect. This is positive yaw going left, negative yaw going right. So that's not bad. It's pretty stable at the limits, and it was just slowly decreasing the velocity I was allowed to have until I got to the limit. So let's see if we can go faster. Because, I mean, I've got plenty of cushion space. If I'm going to try to break the limits, then this is where I do it. So, what's limiting us right now? Is it the proportional gain, or... Let's turn up the proportional gain, turn up max gimbal control rate. That rate is 170. No, we're near a max. So is that limited by the... So that's not going to be limited by the limiter yet. That's going to be limited by the proportional gain. So that bounce back was the limiter gain. We want a wider slowdown extent. This is like this is like how far away the. Oh, this should maybe be different in pitch versus in yaw, because you can get going so much faster in the yaw axis. Anyway, this is so much better than before. This is a good starting point. So actually, I don't know if I want to get all that speed from the proportional gain. I think that's what I want to use the integral gain for. So let's maybe try the integral gain now. Oh yeah, that probably needs a smaller scale. Whoa. Yeah, let's have a smaller scale for that, and maybe yeah, maybe slightly bigger for proportional, but. Yeah, I should really have separate pitch and yaw widths for the slowdown extent, because I want to be able to accelerate pretty fast in yaw, but then I need more time to coast. So I'll just make this a vector. Duplicate it there. Split it up there. Oh, I should maybe. So, you know, I did the thing here with axis to kind of keep this in the local scope. I might do the same thing with limiter and limiter single edge here. This is more self-contained in this function now, though. Oh, the limiter's getting a little more vibraty here than I would have liked. That's pretty nice, though. See, the closed loop drift compensation would be nice. It's actually pretty touchy. And I'm imagining just a slow feedback loop that tries to null out the velocity of the tracked region. So this would probably be the first time we're actually taking the tracked region and just throwing it into a really slow low-pass filter, and then just looking at the velocity of that and trying to null that out towards 0. But that's not implemented yet. Emily is asking if the flyer is automatically using the new code once I'm done with edits. For these particular web browsers it is, because these are the React development server. But for the Rust code, I have to compile it, and it's really slow. Anyway, I think we finished waiting for it to compile just then. Oh, no, maybe we didn't start it compiling. Maybe I got distracted. This is supposed to have 2 values. It's writing the old single value. Yeah, I think I just spaced out and forgot to recompile this. Speaking of the code, where did the top of that window even go? Yeah, what happened there? Oh, that semicolon. Oh yeah, you can hear the heater. I'm right next to the heater. Zuko's still sitting right behind me. If we could turn the gimbal over and watch him. So many files. Let's close these browsers so they don't store old keys. Oh, cat sprites. Yeah, Emily says heaters expanding, contracting, and loud rain on rooftops. Weird how these are relaxing metal sounds. Yeah. Will the server start before we hit the end stop? How's our temperature doing? Oh man, that CPU cooler is great. It's much better. GPU is fine too. Yeah. No. No. Stop that. Why did it go all the way up there? Yeah. Okay. This is working pretty well so far. Let's see if we can get some more of these parameters dialed in. So I want a smaller slowdown extent vertically because the pitch axis is not that big. Pretty wide one on the yaw axis. you know, it's like kind of fun to like figure out, oh, this could go so fast, right? But actually, I don't think I want it to go much faster than this. So otherwise, everything's just kind of a blur, and being able to decelerate enough for the end stop starts to become harder. So right there, I can just go as fast as I want, and then it coasts to a stop around the actual end value. That was weird. Was that the computer vision or something else causing it to jerk over? Oh, there's Tuco. Yeah, and see there, I mean, it seemed like it was tracking fine. There was just some kind of weird glitch, which could have been either the CV or the gimbal. But that right there is pretty good. Just testing out the gains. This is feeling alright for like a slower gain region. Let's see what happens if we add a faster gain region too. So these widths, so 0.3 is about a third of the distance between the center of the screen and the left of the screen. So that seems about right. Can maybe be a little larger for yaw even. Maybe a little less. Okay, so let's try this with a little region. So yaw 0.04, I don't know. And let's try somewhat higher gains. Oh yeah. So there's a second integrator that actually starts accumulating once we get over there, and then we'll actually zero out once we exit that little region. So can we see that on the graph? Yeah, so that first drop is it leaving the first gain region, and then the second drop is it leaving the second gain region. I think we can do something similar with the pitch axis. And these will need more tuning once we're actually trying to track real objects, but let's just try to get there iteratively. Okay, then maybe this is an alright starting point. That's great. A little more limiter gain. Alright, this needs to be checked in. So I think we're nearing the end of my list of like really significant things that I needed to immediately fix. Like the CPU is no longer overheating, and the tracking is no longer wildly unstable, and it has a lot of good tuning parameters. So this feels like a pretty significant milestone. Like this is working alright, and I think the next thing to do is to just finish assembling the winches and get this thing to start moving around the room. That's going to be pretty nice. So let's get this checked in. Oh, Whisperfist got a scanline sticker from Redbubble, and it, yeah. So I guess the stickers and the shirts, everything arrives separately. Like I ordered the stuff from Redbubble to try it out, and I got the shirt and the mug and the stickers all in separate packages. I think they just all get made at separate facilities. Okay, I think this is everything in the Rust repo. Let me just double check that I don't have any lingering changes in the OBS. So this repo itself is a little local fork of OBS Studio, which just has like one random change and mostly includes the plugin as a submodule. Wow, why is this taking a while to run? There we go. So nothing good there. Nothing good there. Okay. Well, I think all the code then should be on the Git organization. github.com/tukoflyer in case you're curious. There's the Rust software, the C++ plugin, the OBS fork, everything else, the firmware, the CAD models. And we're still tracking the cat pretty nicely. So just to quickly explain what these graphs are in case it isn't obvious or I haven't already gotten there. So these two numbers are the pitch and yaw coming from the magnetic encoders in the gimbal. So that includes the motion I'm commanding. It also includes the stabilization that's built into the gimbal. So if I just grab the robot and move it around, like it'll respond here. So a lot of those changes just came from the local gyroscope counteracting all of my motions. But then this yaw, pitch, and rate control, these are actually going from the Rust code to the gimbal firmware, and this is the control to the gimbal. And this is the part of that that's coming from the proportional control in the tracker. This is the part of that that's coming from the derivative control in the tracker. You can see most of it's coming from here right now. But let's try, can I distract the tracker from Tuco? Oh, Tuco's licking me. Oh, that's great. I guess I can use the manual control. But yeah, the scale changes dramatically on the integrated control rate. And now, in longer term movements, that ends up controlling or supplying most of the control. So for little short adjustments, you're mostly proportional control. But for swinging around to something that you're having trouble keeping up with, the integrated rates help out. Yeah, and I think gimbal should be pretty fast. I mean, I'll be trying to limit the acceleration and the motors, are not super overpowered. The motors aren't going to have the winch flying around the room, but I mean, it is the Tuco Flyer. I do actually want it to fly around the room, just not fast enough to require insane amounts of energy or to risk hurting people or animals. So how is this going to keep up with Tuco, I wonder? Well, guess that answers my question. It'd be interesting to go frame by frame and just see how much advance warning I had that he was going to go that direction, if any. I think in the actual Tuco Flyer situation, it would have been backing up a little bit when he was taking up that much of the frame. These will definitely need some tuning, but I think this will be easier to tune once more of the system is built, and I'm not just like unhappy with the way it's built now. I think the algorithm is probably going to be pretty good for a while at least. We just might need to tune the parameters, of course. And anyone who hasn't seen the kind of underlying layers here, so the little cat sprites there are kind of an abstraction of what's going on that hides a lot of the underlying uncertainty. But if we go to overlay and layers, so that's particle swarm, we can also show the raw tracking rectangle, the object detector outlines, so you can see stuff that the computer vision is looking at. Not quite sure where Tuco is. And if I want to see what those are, I can turn up labels. You can see it thinks I'm a human. Silly computer. It actually is quite certain I'm a human. Oh well. Yeah, debug text. Yeah, that's pretty much all there is. Just debug stuff. Emily suggests having a wider lens and then doing a digital zoom for the stream. Yeah, maybe, although I didn't want to lose any resolution. I like having the 1080p. So I'd prefer to set the zoom so that it has just enough context for his movement, which I figure you and I will probably want also. But that we stay pretty close to the action, I would hope. Why is it unstable right there? I'm not used to it being unstable in that region. That might also be something for our to-do list. I mean, it's definitely... I've been planning on looking closer at the parameters we can tune in the gimbal firmware to improve the stability. So that might be something else to look into, but I think for now this is probably good enough to make some more progress elsewhere in the project. Oh, Ryan says I'd probably solve this with an overhead visible or IR camera. That's also part of the plan. There's also a plan to put a camera on the loft. That just hasn't materialized yet, hasn't been the thing to work on. Tuco's milling around there, but... Oh, he's right over here. Hey, Tuc. There we go. There's just so much stuff here. Yeah, so it's doing alright, but... Oh, Tuco. Where'd you put it, boy? Was that a bad throw? I think I threw it somewhere he didn't like. Hey Tuke, was that a bad bolt? The tracking seems better though. Well, thanks so much for stopping by. I think I should wrap up this stream because I don't really have anything useful planned, and now I'm just playing with Tuco, and I should get some sleep soon. But thanks for stopping by. I hope some of that was interesting. Morgan says tracking seems more consistent now than it was a few days ago. Yeah, the biggest change I made to tracking was to make some CPU performance tweaks to the object tracker and change the, I made some both CPU and reliability tweaks. I'll see, now the object tracker's got me. Actually, how well can I, now that Tuco isn't around, can I just wander around and get a sense of how fast it is? Oh, lost it. No. It's not quite tracking me reliably enough, being the dark blob on a dark background. I mean, I could add a config option to turn on person tracking, and then it would be maybe a little easier to walk around and test it. But right now, it's also just having a bunch of problems related to hitting the lower end stop on the pitch axis, which, again, if the gimbal, if it can move around the room, it would just be backing up to give itself more space. And now it just doesn't detect him. It's super distracted. Alright. Alright, well I guess Tuco and I are both getting distracted. I think it is time to sign off. Oh, that's actually a good question. Morgan says, can the gimbal not look directly down? I don't really have a yes or no for that though. Mechanically, it can certainly look directly down. However, it's got this stability problem where if you tilt it too far up or down, then it just starts buzzing really terribly. So that's basically on the to-do list. It should be able to look down and a little further up than we're currently looking, but I have a stability problem that I need to fix before we can really do that. So it's on the to-do list. Anyway, I'll try to make it look less broken later. Oh, and Jeremy asks, as the flyer finds and detects additional objects in the room, can you store that info for simple other tasks like find my keys or find my scissors? Yeah. Yeah, maybe. If the object detector stores classes of objects that would be interesting like that, then for sure. I mean, I could imagine it storing like a context image that's just like the last time it found a certain thing, or a database of things. It's still kind of TBD what I'll want to actually train the object detector on, because that's a bit of a placeholder right now. I mean, it's doing an all right job pointing the tracker at Tuco right now, but it's kind of a placeholder for maybe a more interesting use of the same algorithm with a different network or a different data set. Tuco, is that the bolt? Yeah. I mean, I can try changing that that limit a little bit, but I think it'll get unstable if I do it too much. So you can see up here, angle, the Y angle is like around -400. See, right there it's buzzing. So, yeah, that's just like an unresolved problem. I haven't really investigated where it's coming from. It's just some aspect of the gimbal's control loop internally is getting unstable, and that's manifesting as audio frequency buzzing in the axis. And it's both annoying and probably not good for the motor, so I've been avoiding it. Oh yeah, and as Emily's alluding to, if it is looking directly down, then gimbal lock is going to be kind of a problem. But yeah, I think for various reasons it probably will have a lower limit about how far down it'll want to look. Even just for photography's sake, like I don't think it'll really want to be looking straight down. I think for photography, I would rather just have it back up if it runs out of room. So a lot of the problems right now we're having with Tuco running off the lower end of the frame is just because the camera is right next to where we are, and once it can move around, it'll just be trying to back up when we're too close. So I think that's the idea. Stop this recording before it crashes, because some of that might have been good. Maybe one final CPU temperature check here, since that recording was also going to be warming things up. Oh man, we are staying well below 70. I mean, I guess we had some spikes up to 72, but like, yeah, this is great. Alright. I just upgraded the cooling in this machine, and it took it down by like 20 degrees Celsius, and I'm quite happy with that. Emily is alluding to quaternions. I mean, so actually we're going to have to use quaternions anyway, because the IMU reports its results in quaternions, and I suspect we definitely want to use that instead of Euler angles. I mean, I think a lot of people are assuming that the way to control a robot like this is to have some kind of absolute idea of where it is in the room, but that's honestly not really been an interest of mine so far. That's like maybe a phase 3 or phase 4 kind of thing. But for the first couple of things I want to do with this robot, it really only needs a relative idea of where things are. So, you know, some idea of, is it near the end stops? Is it too low? Is it too high? Does it need to tilt the camera in a particular direction to get a better view? It'll have those kinds of inputs. This is not a bad view right now. Tuco on the floor, staying in frame. All those floating point numbers bouncing around. Alright, well, I think I should get some sleep, and I will let you folks go, but thanks for stopping by, and a special thanks to everyone who supports my stream on Patreon. It means a lot. It's how I keep doing this as the main thing that I focus on, despite all the other many things that humans could be doing. Somehow I can do this, and it'll actually go most of the way toward you know, helping me pay for stuff. So it's been really nice. I appreciate being able to to spend all the time I can doing projects and sharing them. So yeah, special thanks to everyone who supports that. And I'll see you all next time. Happy hacking, folks. Have a nice train on the way out.